Thank you. So is the microphone working? Do you hear me well? Perfect. Awesome. Thank you. Hello, everyone. Welcome. You heard it. That's what I expected to happen sooner or later. I'm a developer evangelist at Twilio, and by show of hands, who of you has heard of Twilio before? Awesome. That's great to hear. Good job, Nathaniel. Everyone heard of Twilio before, so I'm done. No, just kidding. So my talk today is called 422 Unprocessable Entity Suspicious Phone Number. The phone number part is not part of the real HTTP status code, but we're going to talk a lot about phone numbers today, but the rest is a real official status code. It basically means that your server understood the request, but doesn't want to basically respond with a success message because of a semantical problem. So this might be a status code your server could return if someone tries to sign up and you don't want that person to sign up successfully. So you probably wonder, why wouldn't I want someone to be able to sign up for my service? That's the reason why I have the service, to have customers, to have users, which is true when we talk about honest users. But there are certainly users you don't want to have on your platform or using your service, such as spam users, users who create just content you don't want to have on the platform, who annoy other users that really want to use it, or maybe hackers and bots that want to steal data from you. So you want to keep them out and make it as hard as possible for them to use your service. So basically you want to identify real users. There are two common ways to do it. One is with these captchas, but I think now with AIs becoming so smart, actually, machines will do a better job solving these captchas than human in the future. A second thing we often see, how people or how services try to identify real users, is by sending them one-time passwords via a text message. So you know it all, probably you've used it like plenty of times before. You sign up on a website, enter your phone number, your phone buzzes, you get a code, you enter that code on the website, and then you can continue. And I agree, this is also something that can be automated, but it's very expensive for hackers, so you want to make it harder for them. So if they want to do this on a scale, it will get really expensive for them to receive all these codes and to have like these phone numbers running. But now we're talking about user verification, but actually user verification is not the only time when you receive these codes. So one is during sign up, we just talked about it when it happens. So to make sure the user is a real user when you don't know them before. But there are other situations when you receive these codes. For example, to protect logins, to make sure that the user account is safe even if the credentials are leaked somewhere. So basically, whenever a user logs in, that the phone buzzes and user gets a warning, hey, I saw a login on that, from that IP address in that region, was that you? So it could be an SMS, could be any kind of message. I think if you use Netflix for that, you get it all the time, especially if you share it with friends. A third way, when you usually receive these messages, is to authorize transactions. But that you usually only see if you do like important transactions, like if you transfer money, if you withdraw money from your banking app, usually you get one of these messages as well, because the companies, they want to establish trust and tell you that they really care how they treat user data and that you are feel safe with them and that no one easily can steal your money or your data or whatever is offered on the platform. You probably think, if you already know Twilio, sending such a one-time passcode is an easy thing. You just generate a random number, make one API call to send this number to the user, and then you just compare two numbers when the user enters this code on the website or on the app. But it's actually not that easy. There are many pitfalls. So let's talk about a few of them. The first one is additional requirements to your developers. And you don't want to bother your developers, or you don't want to bother yourself implementing business logic or implementing code that's not related to your core business. So whatever you sell on your platform, whatever service you provide, you just want that users who are like honest, who want to use your platform, have a good time and can easily access it. But you don't want to bother about all the details. And the more work this gets, the more distracted they are from what's important and what differentiates you from your competitors. But I'll talk more about these additional requirements in a few minutes. The second part is it can become costly. So it's fairly cheap to buy a number here in the UK and to send text messages to other UK numbers. But then once you get more users, let's say from Germany, where I'm from, or from like France, from the United States, you need to send text messages to different countries, which will get more expensive. You could say you buy a number in that country as well. But what happens if someone from the other side of the world wants to sign up? Do you want to buy a phone number in every country? Or even if you have a lot of users, you would need to buy multiple phone numbers in the same country to be able to serve all of them at the same time, because phone numbers, they basically have a throughput limit, how many text or SMS segments they can send per minute. So in the end, you would do a lot of like number management, and with that number management, you have to follow regulations. There are different parts in the world where it's not as easy to just buy another number and use it. The US is getting more and more strict about it, but also China and Singapore. So these are all tasks you would need to manage if you want to do this on your own. And last but not least, security gaps come with this. One security gap would be like a man-in-the-middle attack, where someone just tries to social engineer the user to give them their code. But actually, I'm talking also about security gaps that directly drain your bank account. So one scheme that we see how this could happen is called SMS pumping. You might have heard about it, or you might have not heard about it. Basically, the story goes like this. You have a sign-up form on your website that's not protected from bots, and there's a field for SMS. And as soon as the user enters any number and their name and hits the form, you send a one-time passcode to that number because you actually want to protect yourself from bots. But this bot here, or this user, doesn't really care about signing up. They just want to trigger as many verifications as possible, which triggers a lot of SMS to a phone number. And the thing about telephony is that basically when you receive, or when I receive a SMS, my carrier gets a little bit of like revenue. They make money the more SMS I receive. So fraudsters might work together with mobile network operators and ask them, hey, if I guarantee that 1 million SMS every month will come to my number, are you willing to share some revenue with me? And then some of them say yes. Usually it's in countries outside of Europe, but some of them say yes, and then money floats back to the fraudster, and they can trigger more and more of these SMS, artificially inflated SMS traffic. And this directly basically drains your bank account because you're the ones sending these SMS. You might think like, I've never heard of that. Is that really happening? Well, I know someone who can tell you it's happening. So this was a popular case from a few weeks ago. You see, like it was middle of February, and Twitter basically admitted that they are being scammed for $60 million every year for fake 2FA messages. And it's not just Twitter. This was just a prominent example. I think in 2019, basically the overall damage from this fraud was estimated to be $3.1 billion. But on the other side, there is also a damage of $130 million with transaction fraud. So transactions that are not secure enough, where someone just steals money, withdraws money because of stolen, leaked credentials. And that basically means you need 2FA. You need to do it right to save money. But if you do it wrong, it also costs you money. So what does it mean, doing it right? Well, you can start implementing solutions on your own. You can install so-called fraud indicators. That means monitor the conversational behavior. Are the one-time codes actually converting? Which means, is the code that I generated ever actually entered on the website? Is the form operated by humans or by bots? You can watch for traffic spikes coming at certain times of the day, coming from certain IP addresses, coming from certain regions, coming from certain numbers. And you can build a carrier ranking just to say, I don't trust these carriers because from experience, I know these. You see them on the right. Basically, these carriers. Oh, okay, I pushed the wrong button. These carriers often work together with fraudsters, so I just don't send any text message to these numbers anymore. So these are all things you could do, but then it's all additional requirements that your developers have to deal with, and they are not able to work on the solution that you actually want to provide to your customers. They're all basically busy working on security implementation. So what you could do instead is use another channel. Just say, I don't want to send SMS. I want to use a channel such as WhatsApp or email where this pumping fraud doesn't exist. Usually these two channels have strong user adaption. It's common to enter your phone number in your email when you sign up for an account, so you're not asking the user to do anything to provide additional information. And it works on Wi-Fi. You don't have to be on cellular network. But also these channels, they have upsides, but also, as always, there are downsides. Emails take some time. The user might not get a notification, or it's just lost because of the spam filter. Similar for WhatsApp, it has the advantage. Users basically, it's almost the same user experience as sending an SMS, but not everyone is using WhatsApp, and you don't know for sure until you try sending the message. So in the ideal world, you basically wouldn't need to bother about these fraudsters. You just want to block the numbers that are fraudulent. You don't want to maintain the list. You don't want to manage your own fraud indicators. You just want to say, I want to send a verification code to that number. If it's probably a good user, send it. If it's not a good user, don't send it. But you also want it to be easy to switch to other channels, such as email or WhatsApp. And this is what I'm going to show you now in the small live demo here. Oh, let's exit the presentation. So what we see here now is the Twilio console. I think almost everyone said they already heard of Twilio, so I jump right into the verify service that I have on the left side here. But you can also find it when you just search for verify services. I just picked the first one. I already have a couple of services here, but I am going to create a new one just for us here. I'm still in the Wi-Fi, okay, that's good. Let's try to refresh. Yeah, maybe that was not the best idea to refresh. Okay, something's coming up. There's already a screen. You see I have some services. I want to say create a new one. I just call this one city.js. And I can select which channels I want to use. I want to use SMS, WhatsApp, voice, and let's say also email. And then zoom a little bit out. So I see the button here. Click continue. And it asks me, do I want to enable FraudGuard? And this is basically what I would recommend to everyone, because this basically has this fraud detection built in. You're not paying anything additional for this. You just say yes, and you're safe that no one can drain your bank account with this SMS pumping attack. And it already created the service. Here on top, you see already the ID of the service that you will also shortly see in the form once it's loaded. And here you see all kinds of verification options that we already discussed. SMS, WhatsApp, email. For email, let me turn on this sender email address. Basically, that would be the sender that sends the OneTime Passcode via email. In case you're wondering how you could create this on your own, there's a link to our documentation. And let's ignore these three for now. So I hit save, and then we jump to the code where I basically create a new file. I think the font size is more than enough. Let's make it a little bit smaller. I say new file, let's call it demo.js. And I also want to install Twilio and .env, these two dependencies. While it's installing, I already start coding. So I say I want to import the Twilio package. Oh, thank you. And then at the same time, I load my environment variables from the dot with .env. So basically, they're stored in a file, and I load them into the environment variables now. They're stored in a file that I have hidden here. That's why I called it hidden env. So basically, you don't see it here, but it follows the same structure as this file. So there are API keys and different phone numbers. And then I can basically initialize the client to say new client or new Twilio. And I pass in my account SID. So basically, this is like username and password for APIs. And my auth token. And then, because I want to use promises, and promises, as you might know, are not OK on top-level files in JavaScript, I just define a async function that I immediately execute here. And now I can use async here. And for that, I want to create I initialize my service object. So I say client, I want to access the verify product, say v2, and services. And in here, I pass my service ID that is up here in the URL, or you also find it here under service SID. Drop it in here, and then it's as easy as saying services service dot verifications dot create, and I say channel. Let's select the channel SMS, and 2 is basically the number of my dev phone. If you now wonder what a dev phone is, you will see it in a second. I just run this code to see if I had a typo or not. OK, perfect. That worked. That went through. Let me actually console log the result that's coming back so you see it as well that it worked. So basically it said, yeah, I sent the code. I actually sent 2 codes because I just ran this code twice. And the dev phone is a developer phone that you can use basically on your laptop to test whatever you want to test with phone numbers, to make phone calls, to receive phone calls, send SMS, and not only send SMS, but also receive SMS. I obviously didn't start it, so I might need to send it a 3rd time. And then the code, the one-time password, shows up here immediately. And the cool thing is that this is a UK number. That's why it's in English. If I would use my phone number here, because I have the German country code, it would immediately come up in German. So you don't have to worry about localization of this message either. Everything will be taken care of for you. So there is this code here now. I now want to see, let's say the user enters the code in your web application, and you want to make sure, is this the right code? Is the user actually in possession of that phone number? So I say service verification checks dot create. So now I don't create a new verification, but a verification check. I say this is the verification that was sent to my dev phone number. And then I can say code. If I do 232 and I run it, I need to log the response again.
I think you have a type.
Oh, where?
Verification.
Yeah, thank you. Verification checks. Thanks. And if I run it now, I had another typo. Oh. Service verification checks create. Oh, do you see it? Let's give that verification checks create 2. Well, let's jump over here to my backup plan to save some time. But I don't need a channel the 2nd time. So, and let's copy the same service SID over here. verification checks. So basically, that was like the wrong code. So it didn't fulfill the promise. But if I copy the right code now, and I run it. Oh, I don't run it. That's the problem. No, node. I just opened the same file over and over again. Yeah. So here, now it says valid true. So basically, this is all you would need to do in the backend. You don't need to store the number, so you don't have to use a Redis cache or something to memorize which code you send to which user. You can just write this code, and it really doesn't matter if you send via SMS or email. Let's do that for a second. This is, by the way, my email address. If you have questions, feel free to reach out to me at any time. And I run the code again. Basically, it said I basically sent the email. And if I look at my inbox here, go to my Sanctuary demos, you see it just arrived here. So this is basically the code I received via email now. And this is all a template that you can configure based on your needs if you want to. But these are only 3 or 4 channels, so voice, SMS, email, WhatsApp, that you can use to send one-time passcodes. But maybe you don't want to send one-time passcodes. You want the users to already have them on their phone. That's possible with time-based one-time passwords. So you see the Authenticator app here, and basically the way it works, when the user signs up for an account, you show them a QR code that is a secret key, and this secret key continuously generates new one-time passcodes every 30 or 20 seconds, depending on the time interval you choose. So the advantage is it works on an offline basis, it's private and secure, so you don't even need to know the phone number of your users. You just show them the QR code when they register, and no one can intercept the code because it's never transmitted until they enter it in your application. And they can bring their own Authenticator app. This is Authy, the Authenticator app that's provided by Twilio for free. But if your users want to use Microsoft Authenticator, Google Authenticator, they all use the open standard and they can bring their own application. So this is, I would say, one of the most secure options. But for many users or consumers today, it might be a bit too hard because they don't really use Authenticator applications on a daily basis. And if you're a bank, you might already have an app that all your customers use. So why not using your own app as the Authenticator app? Well, that is possible with push notifications. And some of your banks probably already use it today. So you log in on the platform, you get a push notification that asks you, hey, do you really want to log in right now? Are you at this location here, Ohio, USA? And is this your account number? So it provides a lot of rich information so your users can actually tell, okay, is this me or is this someone else? And it provides a deny button. That's of all the options that we've seen so far where the users can say, this is not me, please protect my account and lock everything. So it's up to you in the backend to decide what happens. But it basically, there's the option, and this provides even more security and more trust between you and your users. One thing you should consider is push notifications might be blocked or disabled by the user on the phone, so it makes sense to show a message on the website, please check your phone, we just send a notification, or please approve this transaction, please approve this login on your phone. Oh, I was a little bit too fast. So I'd say this is the richest login mechanism that's easy for users to understand, but you might say you want it to be as frictionless as possible. You don't want to bother your users at all. You just want to be on the safe side and have a secure way for them to log on. Well, then silent network authentication, that's a very new thing. It's literally brand new, a couple of months old. It's still in private beta, but I want to show it to you anyway. That's basically a video here that shows silent network authentication on the right side and SMS one-time passwords on the left side. And if I play the video, let's see what happens. So both phones try to log in with the credentials. The left phone will get a one-time password where the user has to wait, copy the code, enter it, and the right one was magically already logged in. And while it seemed like nothing was happening there, there was something very secure happening. Because it's a mobile application, we basically sent a URL to the right phone, and the phone, via the mobile network operator, like EE or 3, I think is another one here, made an HTTP request, and only this particular phone can make that HTTP request successfully. All others won't. So it basically goes to your carrier, the carrier checks, is this the only user who's allowed to execute this request? And if so, you can check it in the backend and to see if that works. I think that I can still do a live demo that shows you this part. For that, we do a role play. I'm the backend. My friend Nathaniel is the front end. Yes, come up on stage. So I don't do live coding to save some time, but basically I do the very same thing as before. I initialize a Twilio client. I particularly initialize one in the data center or with a connection to the data center in Dublin. And I create a new verification service. So I say, I execute this code. This is the ID of the verification service. In step 2, I initialize, or I use this verification service to send a verification, and before I used SMS, or I could have used WhatsApp, but now I want to use SNA. I run the code. Basically in here, I get this URL, and this is the URL you would send from the backend to the front end. So I'll do that on Slack here. I sent you the code, and
I have to disconnect from Wi-Fi.
Yes, you have to use mobile network, because otherwise your operator or your carrier would not know that it's actually Nathaniel who's accessing the code or accessing the URL. And Nathaniel, do you let me know when the page loaded? And here I already can tell you what's happening or what will happen here. I use again the verification checks. So same method as before. I say new verification check with Nathaniel's phone number, but I don't have to supply a code because there's no code involved.
I got a white screen, so I think I'm not sure yet if it's gone through.
So let's see if it already went through. So I execute the code. Okay, it did not load, but I can. Do you think it's still loading, or should I send you a new link?
Can you send me a new one?
Sure.
I think my phone network hadn't reconnected just then.
Okay.
Sorry. The basement's
So in case you're wondering why I use backticks to send a link, because Slack and some email clients, they have the feature that they show a preview of the link, but I don't want that this client accesses the preview. That's why I basically send it encoded like this, because this code is only valid once. So that makes sure that there are no man-in-the-middle attacks where someone tries it with one phone and then the other. So once this link is basically used once, it's burned, and you need to create a new link, which usually is not a problem if it all happens in your application on the client side, because there's only one phone who's trying to access that link. It's not working. I think there's a demo course on the stage. Yeah. But okay.
I'll try it one more time.
I mean, you can let me know when it works. Otherwise, I would continue here. There are only a couple of slides left. So in the end, it's up to you to balance what user authentication option you want to choose. One-time passwords via WhatsApp, time-based one-time passwords, push notifications. And it really depends on your service and your application that you want to provide to your customers, and how crucial you want to, how hard you want to make it for the wrong person or to access something valuable, the right information, and how easy it should be for the right users to access this value. And you're balancing basically development effort, usability, security, and cost. And a complete verification solution might look like this, where you say You want to protect user registration and logins with SMS, email, voice, or silent network authentication, and then consecutive logins and transactions with push notifications to the phone. And all of that should follow pre-approved template, have this fraud guard and fraud detection on, rate limiting, internationalization, basically all of that what is coming out of the box with the Twilio Verify service.
Unfortunately, not.
Okay.
Not right now.
Anyway, that's it. I'm Marius Obert. Thanks for your attention. If you have questions, these are my socials. And this is a promo code if you want to use.